Today I'm going to do proofs. So anything, basically looking at how we do basic GCSE proofs. So prove algebraically that the sum of two consecutive integers is always an odd number. So there's a kind of peculiar type of language to proof. So let's think about what two consecutive integers look like. So we could just say that they were 2n, which is just any number, and then n plus 1. They could also be anything like n plus 1 and n plus 2, although that is beginning to feel a little bit more complicated. They could also be n and n minus 1, because that would be, say if we had 5, that would be 6. If we had 6, this would be 7. If we had 5, this would be 4. Prove that the sum of two consecutive integers is always an odd number. Now, the reason why this will be is because we know that if you do even plus even, that always equals even. So 2 plus 2 equals 4. If we do an even plus an odd, it equals an odd. So 2 plus 3 equals 5. And if we do an odd plus an odd, it always equals an even. So 3 plus 3 equals 6. Now I'm actually going to do the work. So prove algebraically that the sum of two consecutive integers is always an odd number. So two consecutive integers, let's take n plus 1. And that equals 2n plus 1. Now, 2n plus 1 is always going to be an odd number, because 2n is always going to be even. And the reason for this is that whatever we put into something and times by 2, it always comes out even. So if we put in 5, you'd get 10. If you put in 1, you'd get 2. And if we put in 4, we'd get 8. But an even number plus 1 always equals an odd number. And that is why two consecutive integers is always an odd number. Okay, let's just do two more. Prove algebraically that the sum of three consecutive integers is always a multiple of 6. So let's write out our consecutive integers. So we've got n plus 1, and n plus 2. Again, you could have n minus 1, n, and n plus 1, and this would also be consecutive integers. And you can see that there's a range of things that will work as consecutive integers. But let's add them together, so it's the sum. So let's do n plus 1 plus n plus 2. And that gives you 3n plus 3. Okay, and I'm just going to check whether this one works out as well. So watch this. So n minus 1 plus n plus 1 equals 3n, and then those two cancel. So in the case of this one here, this does work out as a multiple of 6. So whatever we put into 1, we will get the right answer. So 1, if we put n equals 1, that would give us 3 times 1 plus 3, which equals 6. If we put in n equals 7, that would equal 3 times 7 plus 3, which equals 24, which is also in the 6 times table. So that one works completely. This one, I might need a little bit more work, because that doesn't, there is only one, I suppose there's only, no, so all the odd numbers when you put them in work. But anyway, oh, even integers, there you go. That's why it doesn't work. Now, I've done this completely wrong, but you've been able to see that not reading is quite an important thing. So even integers are going to be 2n 2n plus 2 and 2n plus 4. Or they could equal 2n, 2n minus 1, and 2n plus 2n minus 2 and 2n plus 2. So either way, you will get, if you add all these together, you'll get 6n plus 6. And if you add all these together, you get 6n just generally. And that means no matter what you put into them, you will always get a, it means you can take 6 out the front. So n plus 1 and 6 times n means anything you times by it will always be a multiple of 6. So that was a nice example of why you should always read the question.